Welcome to numerical processes. We shall be taking on indices. So let's move right ahead. The objectives for today will be one, we're going to review the laws of indices. So we'll also go ahead and solve some common problems in indices. I'll answer a few questions on our own, that's on your own rather, just to be able to find out how well you've understood the topic. So let's dive right ahead. Laws of indices. Below you would find the 4 laws of indices. We have one, which is this one here, right here. Once you have a multiplication of 2 variables with the same with different powers, then what you have is that the variable x, which has to be the same for the 2 angles here and here, will be that same variable raised to the power of the first power here, a, and then b. So we'll add that up to give the answer or the simplification for that indices. For the second one, once you want to divide 2 variables, the same variables but with different power, then the law states that you have the variable x with the power a minus the power b of the second one. Then the third one states that once you have anything raised to the power of 0, it will be 1 for as long as the variable x is not equals to 0. That symbol, which is equals to cancel, means not equal. So for this statement, this goes ahead to mean that if we had something like 2 raised to the power 0, that would be 1, y raised to the power 0 will be 1, 1 million raised to the power 0 will be 1. As long as it's 0, then it's going to be 1. Now, if we're to say 0 raised to the power 0, I mean, that's going to be infinity. Then the fourth law states that once you have a value and a negative power, then that variable, or then you have 1 all over the variable raised to that power. So an example will be 2 raised to the power 1 over 2 will be 1 all over 2 raised to the power 1 over 2. This is actually 1 raised to the power square root of 2, but we'll leave this for now and go there later. Let's try solving a few examples. One example for each law. So this is for the multiplication law, for the division law, for the raised to the power 0 law, and then for the negative power law. For the first one, just like we had, recall that the law states x raised to the power a plus, I'll just go ahead and clean that. A variable raised to the power of a times another variable raised to the power of b will be a variable raised to the power of a plus b. So to answer that question, your guess is as good as mine. You would have 5 raised to the power 7 plus 3, which is going to be 5 raised to the power 10. So that's the answer. That solves the first question on the first law. For the second one, we had, if you recall, that a variable raised to the power a divided by a variable raised to the power b will be equals to that variable raised to the power a minus b. Right? So to solve that question, we will have 5 raised to the power 5 minus 3, which is going to be 5 raised to the power 2 in indices form. So we just leave it there. Let's move over to the third law. The third law states that any value, states that any value of variable x raised to the power 0 will be equal to 1 as long as, that's a caveat here, that's a caveat, x is not equal to 0. So this is assuming n is not equal to 0. And so to solve this, we're going to have 1000 times n raised to the power 0, which will be equals to 1000 times 1, which is equals to 1000. So that's our solution for the third law. Let's go ahead to the fourth one. For the fourth law of indices, let's also recall that if you have a value x raised to the power of a minus a, then that will be 1 all over x raised to the power a. And we went ahead to solve a problem on that. So just the same thing. So you have 15 times 1 over x raised to the power of 5, which will be equals to 15 over x raised to the power of 5. And that's our answer. Thank you for following me ahead with this topic, and I hope you do understand it. Now you have the opportunity of trying a few questions. So let's see how you do. Thank you.